QuHackEd is the first quantum computing hackathon that we're holding in Scotland. The idea behind this event is to raise awareness for this new technology that's becoming available, and we want to educate the wider audience about how to use it and the tools that are going to become available in the next few years, and also to develop new collaborations between academics and industry and the wider audience in general.
It's a meeting for undergraduates, PhD students, and anyone who's interested in quantum computing to come, build up a foundation of the theoretical understanding of quantum computing, and then participate in some up-and-coming quantum programming languages. So we wanted to bring together different groups of people, the industry and the students together, and build collaboration between groups of people who don't usually talk, like compiler theorists, and more theoretical people like programming language theorists.
Do I think there is a good understanding in general of what quantum computing is? I think people roughly know the term, but even in the academic community in computer science, people are not very familiar with it. And it's very difficult to kind of mesh these two fields. You've got computer science on one hand and physicists on the other hand, and then engineers in between. So it's very difficult to connect these disconnected academics, even never mind trying to educate the wider community about it.
Typically, at the moment, classical computer scientists, typical programmers, can get away without understanding the architecture which they're using. In quantum computing, it's a lot more difficult to do that because you have to understand the physics of the system. You have to understand this in order to be able to use it and program it and build it. So typically, while these different groups can get away without talking to each other, in this case, they really need to.
We organised this event because we thought it was a good opportunity to reach out to the wider, in particular, research community in computer science, which is available in the University of Edinburgh. So the School of Informatics is a very strong computer science department, so we wanted to try and tap into that a little bit and educate them as to this new technology that's becoming available. We also wanted to try and educate newcomers to the field who have no experience in a very simple way, so they can learn how to use these tools which are becoming available and will be coming available in the next couple of years. So when quantum computing sort of happens, they're ready to start using it immediately. Quantum computing is a new paradigm of computing that we have not had access to before, and we believe with quantum computing we can solve problems that we could never solve with any sort of computer that we have available now, a laptop or even the most powerful supercomputer. So we're trying to build these devices to harness quantum physics, which behaves very differently than our everyday lives, because the systems that we interact with are very small and they interact very differently to how we experience interactions on a day-to-day basis. So we can actually use these interactions to get some advantages in terms of computation. And there's been a lot of exciting work done in the last few years to see where we can go and what can be done.